Welcome to the deep dive. Today we're getting into something that affects pretty much everyone in a city, traffic, specifically how we measure it. There's this new research paper proposing a whole new approach using some, well, pretty advanced AI.
Yeah, and getting good traffic data isn't just, numbers on a spreadsheet. It's
Yeah.
fundamental for managing a city effectively. Think traffic lights, predicting jams, all that stuff.
Right. But the paper argues that the current ways of doing this, they've got some serious limitations.
Exactly. Big ones. They talk about three main things: missing core functions, trouble recognizing everything they need to, and crucially, unstable tracking, like losing track of cars.
Unstable tracking, so you can't reliably tell how fast something's going.
Precisely. Or even get accurate counts if the system keeps thinking one car is suddenly a new car. It messes everything up. This paper tries to fix that by combining models like YOLO-World, BOT sort, and SAM2 into one system.
Okay, so we're going to unpack this. We'll look at what's wrong with the old ways and how this new combination of AI aims to give us, much better eyes on the road. Let's dive in.
Sounds good. So first, those missing functions. What exactly are they saying a good system should be doing?
Well, they list 5 key things.
Hmm.
You need vehicle density, pedestrian density, speed calculation, counts broken down by type of vehicle, plus pedestrians, and identifying anything that's stalled or stopped unexpectedly.
And the current systems, they maybe do one or two of those?
That's what the paper claims, yeah. Often just basic counts, maybe speed, but not that whole package, which you can imagine really limits a traffic manager.
Definitely. You're flying half blind. And then there's
Yeah.
the recognition problem. You mentioned the struggle to see everything.
Yeah, this is where the closed set detection comes in. It's a bit technical, but basically older systems are trained on a fixed list. Car, bus, person, that's it.
Right. So if, say, electric scooters suddenly become popular, or you need to differentiate trucks from vans, the system just doesn't see them.
Pretty much. It wasn't in the training data. You couldn't even ask it something specific like find the red car or count only delivery trucks.
Not without a massive effort to gather new data, label it all, retrain the whole AI model. It's super inflexible.
Hugely. Especially when cities and vehicles are changing so fast. And that ties into the other big one, the unstable tracking.
Yeah, you hinted at this. If the system keeps losing an object, the data's unreliable, right?
Totally. They mention older methods like basic Kalman filters, which apparently struggle when things don't move in straight lines, which cars rarely do.
Yeah. Or things like deep sort, which is more advanced but can still get confused, especially when one car blocks the view of another. That's called occlusion.
And that leads to ID switches.
Yeah, exactly.
Yeah.
The system thinks car A vanished and suddenly car B appeared, even though it's the same car just reappearing. Your speed calculations, your counts over time, they all become questionable.
So, okay, limited functions, rigid recognition, shaky tracking, that's the background. How does this new proposed method tackle all that?
So the core idea is combining 3 specific AI models: YOLO-World for detection, BOT sort for tracking, and SAM2 for segmentation, plus a data processing module. The goal is comprehensive, adaptable, reliable data.
Let's break those down. YOLO-World first. You said it helps with the recognition problem.
Yes, because it's an open set model. This is the key difference. Instead of a fixed list, it can understand more flexible text prompts.
Text prompts, like I could type in find bicycles.
Potentially, yes.
Yeah.
Depending on its training, you could ask it to identify categories it wasn't explicitly shown during its final training phase, maybe trucks with ladders or vehicles emitting visible smoke. It connects language understanding with visual detection.
Wow, okay. So much more adaptable. No need for that massive retraining cycle every time something new appears on the roads.
That's the promise. It leverages huge data sets, linking text and images. The paper also says YOLO-World performs really well, better than other open set models in speed and this zero-shot ability, meaning detecting things based just on text descriptions. And it's efficient, too.
Okay, that sounds like a game changer for detection. Now, how do they fix the unstable tracking? BOT sort, you said.
Right. BOT sort takes the detected objects from YOLO-World and gives them unique IDs, then follows them frame by frame.
And it's better than the older trackers. How?
A few ways, but a really important one is something called camera motion compensation, or CMC.
Camera motion compensation. What's that compensating for?
Think about the camera itself. It might be on a pole that vibrates slightly in the wind or shakes when a heavy truck goes by. CMC figures out if the camera moved, not just the objects.
So it stops the system thinking a car jumped sideways just because the camera wobbled.
Exactly. It separates camera movement from actual object movement. This massively reduces those bogus ID switches and makes the tracking far more stable, even with less than perfect camera mounting. It apparently also uses an improved Kalman filter and is a bit more efficient than deep sort.
Okay, flexible detection with YOLO-World, stable tracking with BOT sort. What about the third piece, SAM2? What's segmentation needed for?
SAM2's main job here is to precisely map out the road area itself. Not just a box around it, but like a pixel-perfect outline of the drivable surface.
Why do you need that level of detail if YOLO-World already found the road?
Good question. Because a simple box around the road might accidentally include the sidewalk or a median strip or someone's front lawn if the road curves weirdly.
Okay.
And that precision is vital for one of those key functions, identifying stalled objects. You need to know if that slow car is actually on the road blocking traffic
Oh,
or just pulled over safely on the shoulder.
got it. The precise road mask tells you if the stopped object is truly an obstruction. And SAM2 is better than the original SAM.
Yeah, the paper highlights that SAM2 is faster, more accurate, and importantly designed to work with video, whereas SAM1 was more for single images, essential for real-time traffic feeds.
How do I know what to segment? Does someone have to tell it segment the road?
They automate it. The system takes the road detection box from YOLO-World, picks a point inside that box, and feeds that point to SAM2 as a prompt. Basically tells it, segment the thing this point is on.
Clever. What if something's blocking part of the road, like a big truck? Does it leave a hole in the road mask?
Another good point, the researchers thought of that. They used some image processing tricks, edge detection, and something called dilation, to sort of intelligently fill in those gaps in the road mask caused by temporary obstructions. Helps keep a complete picture of the road surface.
Okay, wow. That's quite a setup. Detection, tracking, segmentation. How does all this raw info become actual traffic stats? Speed, density, etc.
That's the final piece. The traffic flow, data processing, and analysis module. It's like the brain, taking outputs from YOLO, BOT sort, and SAM2 and doing the calculations.
So how does it get speed without a radar gun?
It uses the tracking data. BOT sort tells it where the center of a car's box is in frame 1 and where it is in frame 2. The module calculates how many pixels it moved.
Pixels? How does that become like miles per hour or meters per second?
You need two more things. The video's frame rate, how many frames per second, and a conversion factor. Basically, you calibrate it by measuring how many pixels correspond to a known real-world distance in that specific camera view. Like maybe 300 pixels equals 2 meters. It's simple math from there and computationally cheap.
Makes sense. And density.
Pretty straightforward. For vehicles, it counts the number of tracked vehicles within a defined stretch of road and divides by the length of that stretch, say, cars per 60 meters. For pedestrians, it's the number of people divided by the ground area they're in, like people per 600 square meters.
And the stalled vehicle detection, that uses the segmentation, right?
Exactly. It combines speed and the road mask. The system periodically checks objects. If an object is moving very slowly or not at all, and its location significantly overlaps with that precise road mask from SAM2.
Bingo. Likely stalled on the road.
Precisely. Then it can flag it, maybe capture an image, send an alert. It's a direct application of combining that tracking and segmentation data.
Okay, so that's the theory. It sounds impressive. Did they actually test this? How did it hold up?
They did. They built a pretty large custom data set, thousands of images, over 120,000 objects labeled across different categories, captured in diverse real-world conditions: sun, rain, day, night, the works.
And did YOLO-World actually beat the older models?
Yeah, the results seem strong. They compared their YOLO-World setup against older YOLO versions like V3, V5, V8. On their data set, YOLO-World has significantly better precision and MAP. Those are standard accuracy measures. We're talking numbers like, say, 77% precision versus maybe low 70s or 60s for the others.
And crucially, YOLO-World has that open set thing the others lack.
Exactly. That flexibility is a bonus on top of the raw accuracy improvement.
What about the tracking? Did BOT sort prove more stable?
The analysis showed it's a bit more computationally efficient than deep sort. But more importantly, they did tests on a standard tracking benchmark dataset, MOT17. Those tests showed improvements in tracking metrics like AMO and IDF1, and specifically highlighted how that camera motion compensation really helped cut down the number of ID switches.
So the CMC feature actually works in practice.
Good. And SAM2. Confirmed faster and more accurate than the original SAM, especially important for processing video feeds without falling behind.
Which brings us to the big question. Can the whole system run in real time.
That seems to be a key finding.
Hmm.
They measured the total time needed to process one single frame through all the stages: detection, tracking, segmentation, analysis. And the processing time per frame was significantly less than the time between frames, even for high frame rate video. So it finishes analyzing frame 1 long before frame 2 arrives.
Meaning it can keep up with live video feeds easily?
Yep. It demonstrates the potential for real-time deployment in actual traffic monitoring centers.
Okay, so bringing this all together, what's the real-world significance here? What does this mean for you, the listener, maybe stuck in traffic or just interested in smarter cities?
Well, I think the big picture is moving beyond basic, often unreliable traffic counts. This approach promises data that's not just more accurate, but also much richer and more comprehensive.
Like getting speed, density, counts by vehicle type, and stalled vehicle alerts, all from one system, reliably.
Exactly. And having that kind of granular real-time data could allow for, genuinely smarter traffic management. Think traffic signals that adapt dynamically to actual conditions, not just fixed timers.
Or much faster detection of accidents or breakdowns that cause major jams.
Right. Better congestion prediction, maybe more efficient routing advice. And the adaptability from YOLO-World means the system can potentially keep up as new types of vehicles emerge. It overcomes those key weaknesses of older systems,
It really does feel like a potential leap forward, making the data much more actionable.
turning raw video into actual intelligence about traffic flow.
So, to wrap up, this research paper lays out a new method combining several advanced AI techniques to get much better traffic flow statistics. It's more adaptable to seeing different things on the road, much more reliable at tracking individual objects, and delivers that full suite of information speed, density, counts, stalled alerts needed for truly modern traffic management. It's a foundation for potentially much smarter, more responsive urban transportation systems. Which leads to a final thought for you. This kind of technology allows for incredibly detailed, real-time monitoring of everything moving on our roads. When we have that level of constant, granular data where every vehicle and pedestrian's movement and status can be tracked, what new possibilities open up, but also what challenges? Think about dynamic road pricing, automated rerouting, optimizing delivery networks, or even the privacy implications. Something to ponder as our roads get smarter.